Okay, I'll give you some basic graphs that you have to memorize. You know, in the corporate environment, graphs are really important because, I mean, the stock prices, fuel prices, your company's sales, right? All these things, when you make reports, they come out as graphs, right? And when you have graphs, you need to have some basic vocabulary to talk about what these are, okay? So the very basic things that you have to know is some graphs of basic functions. The first, you have y equal to x, the simplest of all. That's the 45 line like that. And the ones that I draw here, you have to memorize, okay? And then you have y equals to absolute value of x. That's a V-shaped one. Now these are something that you can sit down and plug in values to generate the graph one by one, or you can use a graphing calculator, but it's preferred that you memorize this. Y equals to x squared. What shape is this? It's a parabola, right? It's a U shape, right? Okay. Y equals to x cubed. Does anyone know this graph?
Down.
No. Anyone else? Well, if you plug in -1, it does give you negative, so it's under. But if you plug in +1, 1 cubed is +1. So it's something that would cross -1, -1, and +1, +1. Yeah, it's exactly that. So the graph looks like that's the graph. So in motion is like this. Yeah, actually, you can actually make a dance of all these graphs, like y equal to x, y equal to absolute value of x, y equal to x squared, like that, y equals x cubed. All right. So you have y equals to 1 over x. We did that earlier today. Remember that this one has 2 asymptotes. Then you have to know y equals to 2 to the x. When you plug in 0, what's 2 to the 0th power? What's anything to the 0th power? Nope.
Itself. 1.
1. Anything to the 0th power is 1. So if you plug in 0, you get 1. And the graph becomes like, if you plug in 1, you get 2. And it goes up and up and up. If you plug in negative values, it becomes the reciprocal. So that's the graph that you see. Now notice that this graph is increasing. That's also increasing if you only see the right side. So when you describe some kind of a graph that's increasing like that, you can say, oh, this graph is like exponentially increasing. Or you can also say, oh, this is increasing like a quadratic function. Now, exponentially increasing is a really, really scary thing. Okay? For example, if the population of New York City is exponentially increasing, then it's destined to have a doomsday. So it's very bad. Okay? If that's a company profit, that would be like amazing. If you have a company profit that's increasing like an exponential function, that's an amazing thing. Or if it's increasing like a line, you say it's increasing like a line, or it's linearly increasing. Okay? Yeah. Linearly increasing is more realistic. A lot of times companies number, they linearly increase or maybe linearly decrease. Or they could fluctuate, right? We didn't do any sine cosine graphs yet, so I can't show you the sine cosine graphs, but there are graphs that also can manage to explain fluctuating numbers. Okay. All right. Then we have y equals to x to the fourth. And this one's very hard to distinguish from x squared. But if you overlaid it, this is what happens. It's more thick in the middle. Okay, it's like a dull parabola. Okay? This is more pointy parabola. This is a dull parabola. And actually, you don't call that just a parabola. It's just some curve that looks like a parabola, but it's really not. Okay, parabola has some geometric meaning, and this doesn't satisfy that. And then you have y equals to square root of x, and that has a graph that's only on this side. Now with these, let's talk about domain and range. What's the domain and range of y equal to x function? All reals is the domain. You can plug in any number to x. And since the output is that number, what's the range? All reals. Okay, so this one, domain is all reals, negative infinity to positive infinity. And range is also all reals.
Bless you. Thanks.
All right, what about this? Are you allowed to plug in negative values to absolute value function? It's okay to plug in negative, right? It just gives you the positive one, right? What's the domain? All reals. Okay, but what's the range? Or 0. Okay, so remember I said the range is the height of the graph. So since the height never becomes negative, it never goes below the sea level. Sea level is 0, right? It never goes below the sea level. So 0 is the minimum you can get. Okay, so the range is from 0 to infinity, including 0. How about this one? Domain? All reals. Range?
Same as the last one.
Yeah, same as the last one. So this one actually applies to both. Domain? What's the domain? All reals. Range? Again, all reals. We already did this. It's all domain is all reals except 0. Range is all reals except 0. Okay, let's think about this one. See, you can go right or left. They always have some value, right? So this function has domain all reals. What's the range? It can go up, 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 no problem. How low can it go? See, this graph has the x-axis as the horizontal asymptote. So the graph can get closer and closer to 0, but not including. So the range is 0 to infinity, but not including 0. Now this one, again, it hits 0, but it never becomes negative, so this also applies here. Okay, this one. I guess this is the last challenging one. Domain is? Figure out the domain of this. What's the domain?
0 to positive infinity.
Thank you. What's the range? You have to look at the height, right? Does it ever become negative?
No.
No. It's starting from 0, goes up, including 0.
Okay.
Right. So we had a nice practice in reading the domain and range from the graph.
What was the
Huh?
y over 1? Y equals 1 over x.
Oh yeah. So for this one, we did that. Domain is negative infinity to 0, union 0 to infinity, and range is negative infinity to 0, union 0 to infinity. So you have to memorize all these graphs and also be able to figure out the domain and range from the graph.